So the rest of the part ones for the June 2017 exam. For this one, let's see, we want perpendicular. All right, so I've seen this a number of times where students solve the original line that is given, and then they leave that as a choice. Hopefully not. Good. All right, it's not even a choice. Oftentimes, if they leave this as a choice, students will select it. But let's make sure that we don't fall for that. All right, that'd be a good distractor. Next, the slope of this line, it's 3/2. A perpendicular line needs a slope of -2/3. Okay, so right away we should throw those out. Now it's also got to pass through the point -6, 1. Uh, we could use point slope or a graph, which is what I would do in this case. And then apply the slope down to right 3. Okay, and we run into the point, or the y-intercept of -3 down here. So the new equation should be -2/3 x minus 3. Okay. You could have used point slope, or you could have plugged -6, 1 in here and figured out which one of these two worked, but it should be choice 2. Okay. BE is the same as UL. Which information would be sufficient to prove that the quadrilateral is a parallelogram? Okay, so this is one of those things that we'll just have to test all the choices. All right, BL parallel to EU might work, but here's what I've tried to show a lot of students about this. So when you have this situation here, if these are parallel and these are congruent, the trick is that could actually swing over to here, in which case you would have an isosceles trapezoid. So they'd be parallel, these would be the same, right? So that's not sufficient. It is either a parallelogram or an isosceles trapezoid, and that's not good enough. All right, they already gave us, oh, BE congruent to BL. That's not enough because that's these two sides the same. Remember, we don't have a parallelogram, so that's not going to work. Okay, LU parallel to BE, believe it or not, that is enough. If you have a pair of opposite sides that are both parallel and congruent, that is going to be enough to give us a parallelogram. Okay, so that's it. Choice 2. A ladder 20 feet long leans against a building. Okay, so here's the building. Ladder's going to lean. Assume the building and the ground makes a right angle. The ladder is going to make a 71-degree angle with level ground. How high up the wall? Let's call it H for height. Now compared to this angle, okay, that leg is opposite. This leg is adjacent. That's opposite the right angle, so we call it the hypotenuse. Here, let's go ahead and perform the mechanics of our regular trig problems. Now, the choice I would make, since I want this height, is I would use opposite and hypotenuse. Opposite and hypotenuse. You know what? Let's call it x because h could get mixed up there. All right. So opposite hypotenuse is going to be sine. So sine of 71 degrees equals opposite over hypotenuse. Now, I try to teach my students these mechanics. I think that they're, optional, of course. You can do it however you want. But I like going this way. So I type in sine of 71, my calculator. It punches out 0.9455 to 1. That's what I can expect the opposite to the hypotenuse ratio of sides to be. Now opposite, we don't know, but we know the hypotenuse is 20. Now we got a proportion to solve. All right, this is just the mechanics that I teach. Okay. So x equals whatever 20 times that is. I get 18.91. So nearest foot is, we round that to 19. Okay. In two distinct acute triangles, when there's a sequence, okay. So let's do this. This is ABC. This is DEF. They're gonna be, we're already told that those are the same. Okay. If we map angle A onto angle D, that's, and angle C onto angle F, this is angle, 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 which is never good enough. Now, if we go AC onto DF and BC onto EF, that's side, side angle. Again, that doesn't work either. So we got to be careful. The reason, there's a lot of reasons for that. You know, this could swing closer, so it could go there. So it's basically, it could create two triangles, and that's not good enough. All right, so let's get rid of those for a second and start over. Yeah, let's just do that all together. Okay, so try it again. So with these problems, what I want to teach my students is just persevere. You've got to test every single one of these to make sure that you don't miss one that's really should be an easy one to score on. Okay, angle C congruent to angle F, and BC to EF. That is angle side angle. That's one of our triangle congruence theorems. Points aren't going to be enough. They don't give us angles. So unless we have all 3 points, it's not going to work. All right, so it's choice 3. Oh, wonderful. Okay, so the trick on this one is all in the dimensional analysis. So 27 feet is going to throw us off here. We should change that to inches. Okay, so since 1 foot is 12 inches, 27 feet, we should just, it's 12 times 27 for the inches. All right, that's one way you could show the work, sorry. On that, let's just get that number real quick. Get 324. Okay, so we could replace this with 324 inches from here to here. Okay, how much metal to the nearest cubic inch would the railing contain? Oh, it's interesting. What we have to piece together is we have to piece together a rectangular prism, which is the bottom portion. See this part right here? It's a rectangular prism. Plus, you'd have to do a half cylinder. It's hard to see that, but that's what we're doing. All right, let's start with a rectangular rectangular prism first. Okay, so that means this is 1.25 inches high. So that radius will be 1.25. All right. So the volume is length times width times height. This volume's pi r squared h, half. So we better do a half, because it's a half cylinder. Wow, a lot going on here. All right, the length is 324 inches. The width we'll call 2.5 inches. And the height, 1.25. We'll get that number in a minute. Half of pi times 0.25 squared. All right, the height is a little strange on this one. The height, believe it or not, is actually the 324 inches for this cylinder. Now, to explain the height for a prism or a cylinder, technically, it should be whatever shape's consistent all the way through. Now, it doesn't matter with the length times width times height, when you have a rectangular prism, but it is going to make an impact when you have a cylinder. Technically, there are, if you think about it this way, let's say all the half circles were 1 inch thick. There'd be 324 of those half circles would make up that cylinder, half cylinder. So I'll go get that number in a minute, and then we'll see what that is. Okay, so after some calculation, multiplying these together gave me 1012.5. Multiplying all this together, 795 and some other, and then add them. So you'll get a total volume of 1807.7, and we want the nearest cubic inch, 1808. Okay, last part 1. Okay, so we're trying to prove that the triangles are similar. All right, which is not sufficient. Great. Okay, we know that we have a pair of angles in here. Okay, we have the ratio of 2 sides. Okay, so they want these two to be, the proportional side, because if you look, AC and EC are supposed to be corresponding. So AC and EC are corresponding, according to our similarity statement. Okay, so 7.2 to 2.4 is the ratio we're looking at here. Okay, so for a pair of sides, if we use that. All right, if DE is 2.7 and AB is 8.1, the question is, are they equal? So multiplying 7.2 times 2.7, question mark, is it equal to 8.1 times 2.4? So I get 19.44. It's probably going to happen. 8.1 times. Oops. Yep, it's the same. So this is enough information. This definitely is, because what we're going to use here is angle. This one we're going to use side angle side similarity. Give me 1 second. I'm going to go calculate the rest. Okay, so I tested choice 3. If we had 3.6 for CD and 10.8 for BC, those would be proportional. So again, we'd be using side angle side similarity. I tested these as well, and then I went back and realized what I messed up on. So this one, these work by side, 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 right? Here's where I messed up a little bit, and I want to go back to 2. I almost eliminated that. It is not side angle side. Here's where I made the mistake. And be careful of this, okay? It is not going to quite be sufficient because DE is over here and AB is right there. Those sides are in fact proportional, but it's side angle. It's not the included angle. Well, there is no such thing as side angle similarity. So please make sure that you check that one. I almost got tripped up by it, but luckily checked the other things all the way through. Okay. All right, good for the part 1s, and next video I'll have the open response.